everybody, happy Monday. Welcome to biology. So this is the recorded version of today's class. And here's our plan. We're going to play caption that graph as our daily puzzle. And then we're going to have an assignment called graph something, which we will talk about in just a moment. But let us play. I can't go in full presentation mode because for some reason this technology thing is not going to have it. So let's just do it this way. For this graph that you see here, the title is incomplete. So do you think that this graph is showing the percent of people who eat ice cream? Notice we're counting up by age. Or is it the percent of people who drive at each age? Or is it the percentage of people who vote? So pause the video for a second while you decide, and then click play when you think you know, and we can talk about it. So it turns out that this graph is actually graphing the percentage of people of each age who drive. And we can figure that out because if we look here at this point where it goes from 0% up to almost like, 75, 80%, that age is about 14, 15, and we know that that's when people begin to drive. You probably ate ice cream a whole lot before you were 15. You probably cannot vote legally until you are considered an adult, so that would give us evidence that we're looking at a graph of the percentage of people who drive. We can also look at this tail end where that starts to drop again as we get into late 60s, 70s, 80s. We see the percentage of people driving drop. So there's one. Let's look at another example. Would this be the percentage of families, who own a car, or who own a swimming pool, or who own a computer? Pause the video, think about it, get your answer in your brain. And now that you have your answer, it turns out that this graph is showing the the percentage, of families who own a computer. And we can think about that because it looks like it goes from 0 to start this steady incline around 1980. And there were cars before then. They looked kind of weird, but families had cars before then. And we probably imagine that even at this top of the graph, it's showing that nearly 90% of families have whatever this thing is by 2015, and we know that that's probably not true for a swimming pool. So we don't even need this complete information. There's a lot of trends that we can see and get information about just by looking at the data points and seeing at what point on the scale do things change. The scale is these numbers across the bottom or up the side. When do things change? Do the changes make sense for each of these trends? And we can kind of figure it out that way. Let's look at another one. So this graph would be either the number of miles driven per family each year, or the number of meals eaten out per family each year, or the number of hospital visits. Pause the video, get your answer in your mind. And now that you have your answer, the correct answer here is actually meals eaten out. So it's meals eaten out because we can probably imagine, we can eliminate hospital visits because it doesn't really make sense that in 2000 we would have 120 visits per family each year. That sounds like a lot. That would be like going to the hospital every third day. And that might be the case for a few families, but it's probably not the average. And then it also wouldn't necessarily make sense that that continued to incline over these years. So miles driven also probably doesn't make sense. If you think about even just maybe driving 2 miles to school, there and back would be 4 miles. If we've got about 200 school days or something like that, we're already way above 120 miles per year. So that one probably doesn't make sense either. But now what I want you to think about is some of the portions of this graph. So what we have on these graphs is some kind of title. these are incomplete because we're playing a game, but you'd have a title, right, that tells you what numerical trend you're graphing. You would also have labels on each axis. You might know this already from a math class, but this down here is an x-axis where we're plotting the year. And here this would be your y-axis where we see the number of something per family. And then on each axis we have some kind of scale, those numbers. And they in a good graph would increase by a constant increment. So this is like 1960, 65, 70, 75. So it's not just going like 1960, 1961, 95, 2020. Like we have a constant interval that we increase by. And that's going to help the numerical trend be more clear to interpret. So there's a couple more examples you can click through in the daily slides on Canvas if you'd like to. But let's go ahead and just nail down some terms here about variables. So again, this might be review for you, but a variable comes in like two sorts. So if we're doing an experiment or observing some kind of trend, we're going to have an independent variable and we're going to have a dependent variable. Now an independent variable is in an experiment the thing that we control, or in an observation it's the thing that we know before we even start to observe. So in some cases this would be like the year. I'm going to count by fives and I'm going to observe some trend in 1960, 1965, 1970, 1975. I know which years I'm going to look at before I start, and that tends to go on the x-axis. We saw that here in this graph. Our year was the independent variable and it went on the x-axis. The dependent variable is the thing you don't know, the thing that you're interested in probably, the thing that you're going to measure. So in this case, our dependent variable was the number of meals eaten out. So the number of meals eaten out per family was here on the y-axis, and that was what we were going to measure. And we saw that it goes up as the years progress, and that's probably, because eating out has become less expensive, more convenient, a bigger part of just our culture, our society. So that's that dependent variable, the one that you don't know until you do your experiment or make your observations. Now, I want to show you a couple examples. These are fun examples, but these are what you might see on a graph, and I want you to think of this as a checklist. So here's my favorite example. This is dinosaur knowledge versus age. So you'll see that I've got a title, check. It's not really the best title. It could be more descriptive. It could say something like percentage of dinosaur facts answered correctly by age group. But it's a title. I've also got axis labels on each of my axes. These could be more descriptive too, but they tell me what I'm looking at. And I've got equal increments in my scale. You'll notice on the y-axis I have percentages as a scale. And so here my independent variable on the x-axis would be the age, who I look at. And I'm counting by fives, you'll see. And then on the y-axis I've got knowledge about dinosaurs. And I'm showing a score by a percentage. That's probably like percentage of questions answered correctly. We don't have that information. But that's my dependent variable on the y-axis. Now, when you make a graph, you choose your scale. So this person chose to count by fives and include the ages from 5 to 25. Now, if that is all the data they have, then this is a good choice, because if they continued their graph to show until age 100, but they had no data for that, then their data would be scrunched into a very tiny part of their graph. Similarly, they made a good choice here to show the entire percentage range from 0 to 100. Think about this question for a moment. What would have happened if they only showed the percentages from 0 to 30? What misconception might you have about the dinosaur knowledge of a 20-year-old in that case? So what you might think, if this is the top of your graph, you might see this data point up there near the top of the graph and go, whoa, 20-year-olds know a whole lot. Because you didn't quite pay attention to the fact that the graph stops at 30% knowledge. So it's really important that you think about your scales and you think about, how am I best going to show the point I'm trying to make here? So this leads me to your activity. And this is your asynchronous work. This is what I want you to work on, your assignment for today. And I'm calling it graph something. Now I'm saying that so generally because you can graph any school-appropriate numerical trend that you want. It doesn't matter what you graph. I just want you to practice the skill of graphing a data set using an electronic tool like Google Sheets, or maybe you're going to use Excel. I recommend that you use Google Sheets so that you have that skill, you know you can do that. But you could do something very silly. Here are my examples. You could graph the number of TikTok users over the last several years or over the months of 2019 to see how this trend kind of took off. You could graph the pancake flipping accuracy that one has as we age. You could graph the likelihood of someone to willingly eat pickles. This would be probably some kind of percentage. It would be like percent of people at this age that eat pickles. Or you could graph, the likelihood of people to intentionally match their socks. It really doesn't matter what you graph. You're just showing that skill and practicing that skill of graphing something on something like Google Sheets electronically. So an example is that I found data for the Instagram usership by year. This is calculated as like the monthly average users in millions. And I graphed that. You'll notice that I've got a title and I've got axes labels. And so for each year, they averaged the monthly use of Instagram and reported that in millions. And you can see how this social media platform took off between 2010 and 2017. So as far as the source of your data, this is something that you can either find, do some research, or you can make it up. So this is what your graph something assignment is going to look like. You're going to tell me what numerical trend you want to graph here on this line. And then you're going to indicate to me, are these real data or your predictions? Then you're going to report to me what is your independent variable, what is the thing you already know, and what is your dependent variable, the thing you're measuring or finding out. And then you're going to report this data here. And when you're finished reporting the data, you're going to make a Google Sheets graph. So this Google Sheets graph needs to include a title, axes labels. So what is it that you're graphing on the x-axis, on the y-axis? Be descriptive. And an appropriate scale. Remember we talked about equal increments. We talked about thinking about, including the full range of percentages if that's something you're doing. And if you'd like some helpful tips about how to make a graph in Google Sheets, you are more than welcome to access this helpful YouTube video right here. And this will show you how to make a graph in Google Sheets. When you're done, you just paste it right here on the next page, and then you can click the blue Submit button. You'll find this assignment in my Canvas homepage. It's linked into the Monday part of the calendar. It's called Graph Something, or the Wednesday if you're in the B group. It's also linked down here. And this is something that I don't think is going to take you a whole lot of time. But as far as your assignments go, I want you to think about this graph something, and I want you to keep in mind that your biome project is due on Wednesday. So if you have any questions, remember to email me at any time, no matter how big or small the question is. And I hope this helps. See you guys.